let's get on and talk about Quarkus. And so Quarkus has come about for sort of a real good reason, really. And that sort of application architecture has moved on from when sort of Java was originally born. So instead of building monolithic applications these days, as we know, we've sort of moved to, and customers are moving to, more of a cloud native way of building applications with sort of microservices architecture. And we even see customers now moving on from a sort of what I would call a standard microservices architecture, even into serverless architecture and beyond. So starting to combine sort of microservices, serverless and event-driven architectures all together into one solution. And this is something that we still want to do with Java. We still think it's really important for Java to actually play a big role in this space. But there are some challenges around Java that we all sort of know about, and maybe we brush under the carpet a little bit and don't really want to talk about so much. And so that challenge really comes back from when Java, and in particular server-side Java, was sort of born in the late 90s, early sort of 2000s. And back then we were sort of looking at building monolithic applications whereby they would have a life cycle of months, if not years, between patches and changes that we would make to them. They'd be running on a sort of physical or virtual machine whereby the JVM gets access to everything. So the amount of memory it uses doesn't matter. The length of time things take to start up don't matter. There are multiple monolithic applications potentially running on this thing as well. And none of that really mattered. What mattered was that I could actually manage and redeploy my monoliths on this application server as and when I did. So a lot of the work that went into these application servers, and continues to do so, to be honest, even in things like JBoss EAP today, a lot of that work was around the dynamicness of the framework. So being able to have things like dynamic class loading, dynamically redeploying applications, dynamically deleting and adding new applications, all of this dynamicness that would go on. And so there's a lot of noise that sits in these application servers that sort of cause problems when we think about microservice, serverless and event-driven architectures. So we responded to that, and the sort of vendor market and customers and community all sort of responded to that challenge and started creating frameworks. And Graham alluded to one of those at the start there, and that's MicroProfile. MicroProfile is a framework. Spring Boot is another framework that people started using to sort of overcome the size and the enormity of what was an application server and why we were using that application server. So what that meant was that we ended up with these applications that deployed as uberjar type applications. They were smaller in size, and we could change them more often. They had a quicker startup time just because it was just doing what I needed it to do rather than anything else. The challenge still exists, though, with this framework, in that it's still based upon that very same premise of a dynamic application framework. And it is important if I'm sort of sharing an application server, sharing a load and sharing everything, and wanting to patch and update everything that I have. However, most people are starting to look at, if not already, deploying as containers. And if something's wrong with that container, I kill the container and restart the container. If I want to put a new version in or patch my application, I create a new version of the container and then rolling deploy or canary deploy that container into production. I don't need this dynamic application framework anymore. And so all of this stuff causes a problem. So we end up with massive memory size, as we know in Java, often slow startup times because of its history. And so what we find is that a lot of people are starting to look at technologies like Node.js and Go as sort of lighter weight pieces of stuff that they can use. Now, of course, the question comes up, and that's, well, what about all of those Java applications that I've got? What about all my Java skills that I've got? What do I do with those? How can I get a density of deployment and a modern developer framework and a modern architecture, all based on Java, that is just much better? And that's really where Quarkus sort of came about. Quarkus is all about addressing that issue and lowering the footprint to start with of the framework, and then allowing us to be able to get a framework that's both dynamic in terms of capability that it has, but also to run in technologies like AWS Lambda, and to be able to run as Azure functions or anything else. There's lots of different things that it can do. And so the key differentiators in Quarkus are, it is designed for containers. It is designed to run on both hotspot, and it is designed to run as native code using Mandrill VM, which is Red Hat's downstream version of the Graal VM. It is designed to lower the memory usage. It's designed to sort of start up in milliseconds, and therefore becomes very suited to sort of serverless applications. It's also, it also sort of unifies the imperative and reactive application development models into one framework, and that is really cool, and it's something to sort of behold when you sort of see it and start using it. And then also it's designed to say, well, we can make life easier for developers too. We can allow them to run these applications and make changes in real time on the fly, so what we call live coding. But equally, what we wanted to do was, we didn't want to introduce a new framework that meant, well, okay, you've still got to learn a whole load of tools. You've got to learn a whole load of new development frameworks and so on. So the key thing again about Quarkus is that we are typically using the same skills that we would use for building either micro-profile applications, or indeed building Spring applications. So we actually have support for a lot of the Spring capability inside of Quarkus as well. So we're really trying to reuse all of the sort of existing skills we've got. Now, what I just want to concentrate the last few minutes that I've got on is really this sort of container first thing. How is it so quick? And just quickly to explain how that sort of works really. And so through the work that we've done, we actually find that we can have an application that was built on a traditional sort of micro-profile type application framework that would take about 9.5 seconds to start up. If we were to run the same application on Quarkus on OpenJDK, we're looking just over 2 seconds to start that same application up. That's okay. But if we were looking at running it in native code using Quarkus, then we're actually looking at millisecond startup time. So all of a sudden, we now have a Java application that can run serverless and can respond to either events or to API calls in a serverless world in a time that sort of makes sense, as opposed to the 9-second type of time frames. If we were to look at memory usage, again, we see something similar. So looking at the traditional stack, we're looking at sort of 209 megabytes of memory, of real memory. This is rather than heap. So 209 megabytes of memory. That sort of goes down to about 145 megabytes of memory if we run an OpenJDK. And when we compile the Quarkus application down into native code, we're now looking at sort of 28 megabytes of memory. So we end up with an application that had quite a lot of memory resource usage, had a slow startup time, that can now run in a memory requirement of 28 megabytes, and can also run with super fast startup time, so it can run for serverless and those type of things. And of course, I say this, but I recommend that you go and look at the Quarkus website as well, and just take a look at some of the things that customers are seeing when they actually use Quarkus. So seeing big reductions in memory, seeing massive reductions in startup times, seeing greater density of deployment, seeing startup times improving with Lambda. Startup times of Lambda, of course, the quicker it starts, the quicker it executes, the quicker it shuts, the less it costs you to actually execute. And of course, density of deployment sort of speaks for itself. And so what that sort of all means is that we can start deploying applications that are written in Quarkus in the same density of deployment that we could if we were using Node and we deployed Quarkus onto Hotspot, onto a traditional JVM. We could get the same density of deployment if we were then to deploy Quarkus applications in the same way. If we deployed them as native, we could see the same that we would see in density of deployment of Go. So what this means is, what I'm not trying to say is Node.js and Go should not be used. What I'm trying to say is those applications that you currently run and those applications and skills that you have that know Java, then they can be equally as productive and get as equally good deployment on a container stack as Node and sort of Go could as well. So it's a really good thing. I highly encourage people to sort of look at that. Now, real brief, what I wanted to give you a quick view is, well, how does that work? There's got to be swinging around about, right? There's got to be some magic in there somewhere. And it's actually really straightforward. It comes back to this dynamic framework that I mentioned right at the beginning. And so if we look at a dynamic framework, that dynamic framework sort of does almost all of its work at runtime. So when I build my application, I create a sort of an EAR file, a WAR file, a jar file, whatever it is. It gets deployed into the application server, and then magic happens. There's sort of things like bytecode injection is done, all the annotations are read, class path scanning is done, all sorts of things that are done before my application can actually execute. And that whole load of work, it actually still surprises me that that can be done in 6, 7, 8 seconds, as it may be. It's a lot of work that it's doing. Now, bearing in mind,
5 minutes, Phil.
Thank you, mate. Bearing in mind that we're looking at running in containers, we don't need a dynamic framework. A dynamic framework gives us nothing. I don't patch my application in a container. I don't deploy a new application in a container. I create a new version of the container. So I don't need a dynamic framework. So effectively, and clearly the devil's in the detail, but looking at it at high level, what we basically do with Quarkus is we move all of that, as much of that work as possible, to build time. So what we actually create is a jar file that is executable, that just needs to run. And that's how we reduce quite massively the amount of Java that we need, and the amount of memory that we need, and also the startup times become much quicker because of that move everything to build time. Now, how do I actually do that with Quarkus? And again, I'm not going to go through this slide in massive detail today, but what we've done is we've created a Quarkus engine that has pluggable components within it. And the key components are the ones at the bottom. So Jandex, Gizmo, and Arc. And those guys are the pieces that do all of the build time work to actually create my application and deploy it. So for example, Arc is a build time dependency injection engine. So all dependencies are worked out at build rather than runtime. Then what we have are loads of extensions that run on top. And this is how we manage to keep keep the skills that you need the same. So things like we have Spring extensions, Camel extensions, JAX-RS extensions, and so on. So effectively that technology that you already use and those skills that you already have, you can largely reuse with Quarkus. So how do I package an application with Quarkus for deployment? No different to any other way that you would do it. So Maven package. Now how do I deploy it so it becomes native code? That's no different either, really, apart from it has a -p for profile native on the end. And that will actually now create me an executable application that works. That process takes a lot longer than just packaging the application. And that's because it goes through all of my application code, all of the JVM code, and determines which of those Java classes, both in the JVM and in my application code, that are actually used at runtime. And it's only those Java classes that end up in my executable. And that's how we see a massive shrink down in memory size. And it's also how we see a massive improvement in startup, just because the thing is much smaller that we're actually executing as a result of that piece of work. So I'm pretty much going to leave it there. So if you want to get started, and I really encourage you to look at Quarkus, there's sort of 3 places that you can go. So if you wanted to use microprofile, you can go to the microprofile, start.microprofile.io site, and you can create a sort of skeleton application there that is ready to go with Quarkus dependencies all built into it. You can go to the Quarkus.io website and you can do a similar thing, but in Quarkus.io, you can also include lots of things that aren't part of microprofile. So if you wanted to include Kafka streaming, or if you wanted to include Camel, you can do that on the Quarkus website. And by the way, the Quarkus website is a really good resource as well. And as Graham and I have said on lots of times, if Carlsberg were to build a community-based website, it would probably look like the Quarkus website, we'd imagine. If you are a Red Hat customer and you want to use a supported version of Quarkus, then you can do that too. So just quickly there was another slide that's gone. Somebody killed my slide. Anyway, quickly to summarize, the idea is that we basically remove that dynamic framework from the solution, which makes things a lot quicker. And if we choose to, we can also remove the JVM from the total solution as well, which allows us then to get even a small amount of memory requirement and even faster startup. So we sort of change dramatically the way the actual server-side stack works, yet requiring the same skills that we would normally see in Java server-side development. So highly encourage people to take a look. If you're going to run Java in containers, you have to look at Quarkus because it is so much faster and so much denser deployment than anything else that's really there. Thanks, mate.
Brilliant. Thank you very much, Phil.